Alrighty, guys. So the first type of problem that you will see on your exam on Wednesday is going to be on the topics of isotopes and ions. I know it's been a while since we talked about these. So if you guys don't remember, isotopes are different types of the same element, and ions are atoms that have a charge. Okay. Okay, so isotopes, yeah, what's up? Yeah. Okay, so isotopes are different types of the same element, and ions are going to be atoms that have a charge. And again, if you guys feel like you guys are able to do these problems on your own, since we have learned these concepts before, you can kind of zone me out for a little bit and just check your work at the end, but I'm going to take a step-by-step for everybody. Okay, so isotopes are determined by the number of neutrons in an atom, and the ionic charge is going to depend on the number of electrons. So here we have a big symbol, 30 on the top left, Al, and then 3 plus on the top right. Now this number on the top left, we call this the mass number. Okay, and the mass number is going to be the number of protons plus the number of electrons. So protons plus neutrons, sorry. The mass number on the top left is going to represent the protons plus the neutrons. Okay. The number on the top right, this is going to be the charge of the atom, and the charge, the formula for charge is going to be protons minus electrons. Okay, so you will need to memorize these equations for the exam because I'm not going to be giving them to you. So just make sure that you guys keep that in mind. You have to know these equations in order to do these problems, and I will not be providing these for you on the exam. Okay, and again, if you guys think you're able to solve it now, go ahead and try that, but let's go through this. So for the mass number is 30. So we're gonna put 30 for the mass number equals. Now we need to know the number of protons to find the number of neutrons. So if our atom is aluminum, how many protons does aluminum have? You guys can check your periodic table. How many protons does aluminum have? Yeah, 13. If you look on the box with Al, the number on top is 13. So aluminum is going to have 13 protons. So we're going to plug in 13 right here. Okay, from there, it's very easy to calculate for the number of neutrons. You just need to do the mass number, which is 30 minus 13 protons, and that will give you your number of neutrons. Okay, so that should give you 17 neutrons. Okay, so just by doing that problem, we have two of the values the problem asks for. We have the protons, which is 13, and we also have the number of neutrons. And again, you will be calculating for these on your exams. So just make sure that you guys are comfortable doing that. Okay. All right, so I'll leave that up there for a second, but take a minute, work with the person next to you, and calculate the number of electrons now. Okay, you're going to be using this formula right here. Charge is protons minus electrons. So I'll give you guys a minute to calculate for the number of electrons on this atom. All right, so I'll give you guys maybe 15 more seconds to finish that up. We're going to be calculating for electrons. Alrighty, guys, let's calculate for the number of electrons now. So if we look at this atom, what is the charge on this atom? What's the charge? 3, yeah, positive 3. So we're just going to plug in 3 right here. We said aluminum has 13 protons. And so the number of electrons is going to get us to 3. So this is a very simple problem. All we need to do is rearrange it. Or you could have just done the number of protons minus the charge. So 13 minus 3 is going to give you 10. So in this atom, we have 13 protons, 17 neutrons, and 10 electrons. And that's what these symbols mean. Okay, so get comfortable looking at these symbols. We have a couple practice problems like this on the unit review. You should be able to find the protons, neutrons, electrons using the symbol, but you should also be able to use protons, neutrons, and electrons to write the symbol. Just make sure the mass number goes on the top left and the charge goes on the top right. Okay. Alrighty, any questions about this one? I know it's been a very long time since we've done these types of problems, a couple weeks now. All right, but if not, let's move on to the next question. Now, again, this lecture is being recorded right now, so if you guys miss something or I'm going a little too fast, let me know. I can slow it down, but this will be uploaded on Canvas for you guys to rewatch if you guys want to review the information, okay? So let's move on to number 2. Okay, so the second topic that's going to be on your exam is going to be about just chemical equations in general and how to read the formulas for molecules. Now, if you guys remember, the reactants are going to be the things on the left side of the equation. Reactants are the things that you start with. So it's your starting materials. Okay. And then the products are things that you make. So things made. Okay, so these are like recipes. The things on the left are your starting ingredients, what you start with. And the things on the right side of the arrow are going to be your products. So for this problem, you're going to have 2 reactants. Your first reactant is CaOH2. Okay, the molecules are separated by the plus signs and the arrows. And so the first one right here on the left side of the plus sign is CaOH2. And then your second reactant is going to be CO2. Okay, reactants, again, are the things that are made or that you start with, and it's going to be on the left side of the chemical equation. Okay, which means that your product is going to be the thing that's on the right side of the arrow, and so you only have one product. It's going to be Ca parentheses HCO3 parentheses 2. Okay, and that's pretty much it. So on your exam, you will have a chemical equation like this, and I'm going to have you guys identify what the reactants are and what the products are. But this part should be pretty easy. The left side is going to be the reactants. The right side is going to be the products. Okay. Okay, so if you guys are good with that, I'll give you guys about a minute. Try to solve this problem out. I want you guys to find how many of each element is inside of this molecule right here. Okay, I know we haven't done these in a while either, but take a second to do that. You can look back at your notes to see how we calculated it, especially with the parentheses. But take a minute to find out how many of each element is in here, and then we'll move on to the next topic from there. Okay, take about a minute. Alrighty, guys, maybe about 20 more seconds to finish that one up. Okay, guys, so if you're finishing up, feel free to wrap up that problem, but I'm going to start going over it for the sake of time. So our first element is going to be Ca. Okay, we see calcium right here. Now, how many calciums do I have inside of this molecule? One. Yeah, there's no number behind it, and if there's no number, it means that it's going to be one. So there's one calcium. Okay, so that part's pretty easy. The parentheses is where it gets a little tricky, but as long as you remember, you multiply everything on the inside by the number on the outside, shouldn't be too hard. Inside the parentheses, there's only one hydrogen, right? Because there's no number. So 1 times 2 is 2. So you're going to have 2 hydrogens. Okay. Same thing with carbon. There's no number behind carbon. So you're going to have 2 carbons because you multiply by the 2 on the outside. And then lastly, oxygen, there's a 3 next to it, but it's inside the parentheses with the 2. So you're going to have 6 oxygens. Okay, so 1 calcium, 2 hydrogens, 2 carbons, and 6 oxygens. And if you're able to get that on your own, should be in pretty good shape for reading the molecule formulas. It's not going to get much harder than that on the exam. Okay. So I'll give you guys some time to copy that down, but do you guys have any questions? It's a little too early for this, huh? You need to wait till at least like 5 p.m. All right, guys. So the next topic that we're gonna go over, it's important for your upcoming exam, but I also do want to let you guys know this is gonna be the basis for the entire second unit for this class. It's gonna be talking about most common ions and how they connect with each other. And so I just really want to encourage you guys to focus on this topic a lot. Make sure out of all the topics on the exam that you focus on this one and get this down. Because if you're not able to get this down, it's going to come back to bite you in the butt for the second unit. Because everything in the second unit is going to be based on this most common ion thing. Okay? All right. So in this question, it's asking us to find the most common ions and to figure out how many electrons they will gain and lose. Now, in order to do that, what we have to do is we need to look at the periodic table. So everybody either pull out your periodic table, grab one next to you. If you have your personal one, that would be best. If you don't have a personal one or you lost it, then you could pick one up by the stack at the door, but you can do that later. Okay. So for most common ions, there's a pattern that you need to memorize for the exam and for unit 2. Everybody in this first column wants to be +1. Everybody in the second column wants to be +2. These guys in the middle, there's no real pattern, so we're just going to kind of leave it blank. We're going to skip these for MCIs. Everybody in this column, 13, is going to be +3. This column right here, they're going to have no MCI. This one is -3, -2, -1, and then no MCI. Again, you have to memorize this for the exam. I will give you guys a periodic table, so you don't need to memorize where the elements are, but I'm not going to give you guys this pattern. So you're going to have to memorize this part right here. Okay, but not too bad. I memorize it as 1, 2, 3, none, 3, 2, 1, none. Okay. Okay, so if we look back at the problem that we're going over, I'll put that back up. We're going to be looking for the MCIs for potassium, silicon, and iodine. Don't worry, I'll put the pattern back up. Okay, so I want you guys to take about 30 seconds. I want you guys to find potassium, silicon, and iodine, and I want you to find out what their MCIs are using this pattern. Okay, shouldn't take too long as you can find them, K, Si, and I. And then after that, we'll finish up this problem. Alrighty, guys. What did you guys get for potassium's MCI? Yeah, +1. Okay, because it's right here. It's in the +1 column. So we just write plus on the top right. Okay, and so if potassium became +1, did it gain or lose electrons? Lose. It lost an electron. I know it's kind of weird. It's been a while, but if something becomes positive, it means it lost an electron. Can you get that for me? Okay, if something becomes positive, it lost an electron. Make sure you guys write that down somewhere. Okay, and the reason why is because electrons are negative. It's like a negative person in your life. It's like me. I just make your life worse. And so if you got rid of me from your life, you would become more positive, right? So that's basically what potassium is doing. Okay, so potassium becomes positive because it got rid of Mr. O from its life, and now it's a lot happier. Okay, it lost an electron. Okay, silicon, what did you guys get for the MCI? Yeah, none, right? So you would just write no MCI because it's in the column with no MCI. Silicon has no MCI, doesn't want to do anything. And then lastly, iodine, I think you guys got the pattern. Iodine is going to be -1 because it's in the -1 column. Now, did iodine gain or lose electrons? It gained, yeah. It became sadder. It met Mr. O. It came into his chemistry class, and now he's sadder. So you guys, this is you. You guys are iodine. That's why it's I. Iodine. This is you. You became sadder. You gained 1 electron. Okay? So that's how you find MCI. Not too bad, but what we're going to go over now is what happens when these ions combine together. So if you guys take a look at the next problem, we're going to be looking at what happens when barium and chlorine's MCI react with one another. Okay, so if you guys take a look at the periodic table, just take a look at barium and chlorine, and I want you guys to just write their MCI somewhere on your paper, barium and chlorine. Okay, just write it somewhere on your paper because that's what we're going to be working with today. You got it? Genius.
Are you recording?
Yeah, I am. Okay, so barium and chlorine. All right, so hopefully you got barium 2+ and chlorine Cl-. So barium's MCI is Ba2+ and Cl- is chlorine's MCI. Now, what we're going to do here is we're going to try to write the equation for when these two things combine together. So we said before that positive and negative charges are attracted to each other, right? So barium and chlorine want to combine, but if you notice, barium is too positive, it's too happy. And like we said, if we have a friend group, right? And if it's too much positive energy, it kind of just gets annoying and the chemistry doesn't work out. So you need a little bit of negative energy to kind of balance out the super happy people. So how many chlorines will I need total to balance out the barium? How many chlorines do I need? 2, yeah, because each one is -1. And so if I have 2 of them, they'll be able to balance out this super happy barium. And so what that means is we're going to write the chemical equation like this. Ba2+ plus Cl-, but I need 2 of them, so I'm going to make sure to put a 2 in the front. And that's going to make BaCl2. And so for your exam, this is what you're going to want for your final answer. This is what you'll have to give me, and it'll need to look exactly like this. Okay, with the charges on the top right, and the numbers have to be in the correct place. Now, I do want to distinguish the number in the front. The 2 in the front here means that the chlorines are separate. Oh, I spelled that wrong. Okay, the chlorines are separate. If the number in the front means that they're separate individual ions. The bottom number here, it means that it's part of the same compound. Okay, and so on the left side, the chlorines were separated and then they combined to form a compound where there's 2 of them. So you can't do this. If you did this Cl-2, this would be incorrect. Okay, and it would also be incorrect if you did this Ba2Cl. Okay, that means that there's 2 bariums, not chlorine. So both of these would be incorrect. So make sure you guys are clear about where to put the numbers. Okay, so just to help you guys visualize, this is what the reaction looks like. You got one barium floating around, you got a Cl minus floating around, you got two of them, and then they're gonna combine and they're gonna form one molecule, BaCl2. Okay, yeah, what's up? Yeah, so we knew that we needed two chlorines because if you notice, the charge on barium is +2 and Cl is minus, right? Which means -1. So that means you need two of them to make -2 so that it can balance out the +2. Yeah. You want to make sure that they're balanced when they combine together. Okay, good question. Okay. And again, I want to encourage you guys, make sure you guys get this down because it's not going to be helpful just for the exam, but also unit 2 is just going to be all this. We're just going to be doing this constantly for weeks and weeks and weeks, just these kinds of ionic reactions. Okay. I know, yes, so exciting. But we're going to be doing our first labs. And so that's something to look forward to. Yes. Or you're going to be working with actual chemicals. Crazy. I know it is scary. I'm kind of worried. I don't know if I can trust all of y'all. I don't know if I can trust myself, actually. All right, let's move on. So we got two more topics to go over. The first one, the second to last one, you guys should be familiar. It's just shell models and Lewis structures. And then the last one is super quick. So let's get through this one and then we'll finish up the lecture. So here it's asking us to draw the shell model and Lewis structure for lithium and lithium's MCI. I know the MCI ones are killer. Now I know we did this recently, so I'm gonna give you guys maybe about 2-3 minutes, and I want you guys to try this out. You can work with your partner, but you're gonna be drawing the shell model, the Lewis structure for lithium and lithium's MCI. So try that out. Take about 2-3 minutes to try that out, and then we'll go over it together. Okay. All right, guys, so I'll give you guys another minute to try this out. At least try to get the shell and Lewis for lithium. Okay, if you don't know MCI, that's okay. We'll go over it, but at least try to get it for lithium, regular lithium. Alrighty, guys. So I want to give you guys some time to work on the review on your own at the end of class. So let me start going over this. But if you're still working on it, feel free to finish up and just check your answers at the end. Okay, so let's start with lithium. Okay, so if we look on the periodic table, lithium is on the top left-hand corner. And so lithium is in the first column. So lithium's MCI is +1. And since it's on the second row, that means we know lithium has 2 shells. Okay, so we just figured out that lithium's MCI is going to be Li plus. And we know that lithium, regular lithium, is going to have 2 shells. So if I drew a picture of lithium, I would draw Li, and I would draw 2 shells around it. Okay. Okay, so lithium is going to have 2 shells. Now, lithium's atomic number is 3, which means that if it's neutral, it has 3 electrons, same as the proton. So I have to draw 3 electrons on the shell. So 1, 2, 3. And that's what lithium's shell model is going to look like. Now, if I wanted to draw the Lewis structure, all we need to draw are the valence electrons. And the valence electrons are the electrons on the outside shell. So there's only 1 electron on the outside shell. So that means lithium has only 1 valence electron. So if I was going to draw the Lewis structure, I would just need to draw Li and then put 1 electron next to it. And that's it. That's going to be the Lewis structure for lithium. Lithium has 2 shells, 3 electrons, and 1 valence or outside electron. And since it only has 1 electron in the outside shell, you only need to draw 1 electron right here. Okay? So that's regular lithium. Now, lithium's MCI, Li plus, is a little bit trickier because when lithium becomes Li plus, does it gain or lose an electron? Yeah, it loses an electron. Okay, it loses 1 electron. And so what happens is we have regular lithium, but it has to get rid of the electron from the valence or outside shell. So if we lose an electron, is there anything left in the outside shell? No. So if there's nothing left on the outside shell disappears too. And so this is what lithium's MCI, Li plus's shell model is going to look like. I'm just going to copy it down right here. We're going to write Li, but you have to write plus so that the person looking at your work knows you're talking about the MCI. It's going to have 1 shell, and it's going to have 2 electrons in that shell. Okay, and again, the reason why it lost a shell is because it lost an electron on the outside shell. Okay. So if we just kind of take an account of Li plus only has 1 shell. It has 2 electrons because it lost 1, and it's going to have 2 valence electrons because the first shell is the new outside shell now. And so if I wanted to draw the Lewis structure, it would be Li plus, and I would have to draw 2 electrons next to it. Okay, and so there you go. I guarantee you're going to have to do a problem like this on your exam where you draw the Lewis structure for something that loses a shell. So just make sure that you're comfortable doing this. Okay. All right, so with that being said, take about a minute if you're done with number 6 to try number 7. I want you guys to find selenium SE's MCI. I want you to draw the Lewis structure. So you don't need to do all the shells. You just need to do the electrons on the outside shell. So take about a minute to try that, and then we'll go over it together before moving on to the last section for today. Okay, you're going to be looking for selenium SE's MCI. Yeah, all the ones that needed to. There shouldn't have been that.
No, there's a way to.
Just refresh just to make sure. I'll double check. I'll get back to you. Alrighty, guys, maybe 30 more seconds to finish that up. All right, guys, let's go over this problem and then we'll move on to the last section. Okay, so if you find selenium on the periodic table, it should be right here on the right side. Now, selenium, so if we look at regular selenium, let's count how many valence electrons we need to draw. So I'll draw regular SC. Regular SC has 1, 2, 3, right? Because we skipped this entire section for valence electrons, 4, 5, and 6. So selenium is going to have 6 valence electrons. So for your picture of selenium for SC, you should have 6 electrons around it. And again, it's because when we do Lewis structures, we skip groups 3 through 12 when we count the valence electrons. Okay. All right, now we need to, the question isn't asking for selenium, it's asking for selenium's MCI. And so selenium's MCI is -2 because it's in this column. So that means we need to draw the Lewis structure for Se2-. And so if selenium becomes 2-, does it gain or lose electrons? Yeah, it gains 2 electrons. See, you guys got it, so easy now. So what that means is, it's going to gain 2 electrons on the outside. So we started with 6, but if it gains 2, it's going to have 8 on the outside shell. So this is going to be your final answer. Okay. Easy peasy. All righty. So that's going to be it for MCI today. Do you guys have any questions? Yeah, what's up? Total electrons? Yeah. So if you look at, if you have a element without a charge, right? Like SC right here has no charge. All you need to do is count the number of total electrons is equal to the number on the top. So for lithium, regular lithium has 3 protons, right? And so if it doesn't have a charge, that means it has 3 electrons. That's how we knew to draw 3. But for valence, it's just the box number. So lithium's the first box in the second row, so it has 1 valence. Okay. Alrighty, guys, let's move on to the last question, and then we'll be all done for the day. So the last question is going to be the last thing we talked about in this unit about metals, non-metals, or metalloids. Now, metals, we said, are going to be on the left and middle of the periodic table. Non-metals are going to be on the right side. And then the metalloids are kind of weird because they make like a little staircase down the middle, kind of right part of the periodic table. Okay, so you don't need to memorize all the metalloids or where things are, but as long as you know generally where they are, you should be good. So just know that metals are left and middle, and non-metals are to the right, and that should be a pretty good guideline. So with that being said, I want you guys to take a second to find out if cobalt, silicon, and xenon are metals, non-metals, or metalloids. For this problem, you're going to have one of each. So if you guys are able to use the guidelines to figure out which one is which, you guys should be in pretty good shape. Okay, metals are on the left and middle, non-metals are on the right, and the metalloids are kind of in the middle-ish. But again, for this problem, there's going to be one of each. Alrighty, guys, so let's finish it up. So first one, cobalt right here. Is it gonna be a metal, non-metal, or metalloid? Metal, easy, right? It's in the middle. Okay, silicon was the one that was kind of weird because it's like here-ish. So let's look at xenon. Xenon's the more obvious one. Is xenon gonna be a metal or non-metal? Non, yeah, because it's on the far right. Okay, so which tells us that silicon in this case has to be a metalloid. Okay, because we had one of each. Now, the metalloids, again, are the weird ones because they make like this weird staircase. Again, you don't need to memorize the metalloids, but if you guys are able to figure out which ones are metals and non-metals, that kind of lets you predict what the metalloids are. Yeah. So for metalloids, they're kind of here. Aluminum we know is a metal because we use foil, right? But just for the exam, I'm not going to be too specific with like the metalloids and stuff. Just as long as you know where the metals and non-metals are, you should be okay. Yeah, good question. Alrighty, and that's pretty much it for Unit 1, guys. We went over all the types of questions that'll be on the exam. Do you guys have any questions? Okay, so again, this will be uploaded on YouTube, so on Canvas. So if you guys need to take a look at the video to refresh your memory, you guys can. And I'm gonna do my typical YouTuber outro. Like this video, smash the subscribe button, join my Patreon and my Discord, and yeah, I'll see you guys later.